Here's a question that trips up students who think they already get this. If I tell you f2, 7, what is the limit of fx as x approaches 2? The answer is, you literally cannot tell. You do not have enough information. Most students walk into limits thinking the limit is the function value. It is not. The limit and FA are two completely separate conversations, and the AP exam is built to punish everyone who confuses them. So before we touch a single formula, we're going to fix that assumption right now. A limit answers one question and only one question. What is fx approaching as x gets arbitrarily close to a without ever landing on a. Think of it like this. You're walking toward a door. The limit describes where you're headed. Whether the door actually exists, whether FA is defined, that's a completely different question. Look at this graph. As x approaches 2 from both sides, the curve is clearly heading toward y approaching 5, so the limit is 5. But f2, the actual function value, is 1. Those two numbers are not contradicting each other. They're answering different questions. This is the structure you need to hold in your head. 3 separate values at every point. The left-hand limit, what fx approaches as x, comes from the left. The right-hand limit, what fx approaches as x, comes from the right. And fa, the actual function value at that point. The limit exists if and only if the left-hand limit equals the right-hand limit. FA has no vote. FA can be undefined, wrong, missing. The limit still exists if the two sides agree on where they're heading. This is exactly what a table of values is doing on the AP exam. It's not asking you to compute, it's asking you to see the approach. Watch both columns squeeze toward the same number. That number is your limit. Yes, absolutely yes, and this is the exact scenario the AP exam loves to put in front of you. Consider f ichi, fiang, x2, 4, kichi, 2. Plug in x ichi 2 and you get 0. The function is undefined at equals 2. f2 does not exist, but watch what happens when you factor x squared minus 4 factors into x2, x plus 2, the x2 cancels, and you're left with x plus 2 as long as x is not equal to 2. As x approaches 2, x plus 2 approaches 4. So the limit is 4, even though f2 doesn't exist. This is not a trick. This is the mechanism of limits. You are describing behavior in a neighborhood around a point, not behavior at the point. Now let's talk about when limits fail to exist, and because that's equally important. If the left-hand limit and the right-hand limit disagree, the overall limit does not exist. Write DNE. On the AP exam, the limit does not exist is a complete, correct, full credit answer, but only when you can justify it by showing the two sides point to different values. Left limit is 3, right limit is 7. They disagree. Limit does not exist. This is a language-precise answer. DNE because the left-hand and right-hand limits are not equal. Mechanism over memorization. 3 things that should be locked in after this. 1. A limit describes behavior near a point, not at it. 1. A limit describes behavior near a point, not at it. FA and lim fx are 2 different answers to 2 different questions. Never conflate them. 2. A limit exists if and only if the left-hand limit and the right-hand limit are equal. Both sides must agree. 3. On any table or graph problem, your job is to read the trend, not grab the closest value. Watch both sides compress toward the same number.